Okay, cool. 312 burst balloons. Given n balloons indexed from 0 to n minus 1, uh, man, that's not a complete sentence. That's why I read that a little weird. Anyway, each balloon is painted with a number on it represented by array nums. You are asked to burst all the balloons. If the what if the I guess what if the u burst balloon I if you burst balloon I, you will get num sub left times num sub I times num sub right coins. Here, left and right are the adjacent indexes of I. After the burst, the left and right then becomes adjacent. Find the maximum number of coins you can collect by bursting the balloons wisely. Okay. And some stuff about boundary conditions, and you have n is equal to 500. Okay. Uh, that was kind of fun. Okay, please don't, no spoilers then. But you can watch me struggle, but please no spoilers a little bit. Okay. So my first inclination is just try to think, is this greedy? And usually it's not. And I explained this a couple of times, but I feel like greedy is always like a trap. Uh, and if that's the case, then maybe it's dynamic programming. But what is the dynamic programming, right? Uh, because this is only adjacent, right? So it's not like you're not splitting things in half necessarily. But and how do you keep track of? Because things now become adjacent. Okay. I'm still so right now I'm still thinking about dynamic programming. I'm just trying to think if it is dynamic programming, how do I, what is the DP on? Also, please don't give me hints for this one for a little bit. I think one thing that I am a little weak on, despite what other people say, is that I am a little weak on dynamic programming. So I think I'm just, so if I ignore the comments, it's not me trying to be mean. I'm just trying to be, trying to figure out this one a little bit on these things. But yeah, I would say dimensional analysis, n is equal to 500. So I could probably do stuff that's n square, maybe n square log n if I want to do it that. But what does it mean to burst a balloon? How can you do so? As a DP problem, I would think about how to describe. Let's say I burst one balloon. How do I? Are these all? Oh, I guess n could be 0, so that kind of throws things in the loop a little bit. But yeah, how do I describe the subproblems in that case, right? And if I have n square array, how do I describe that dynamic? Like, how do you solve it, right? What are the subproblems? Well, if I burst this, if I burst a random number in the middle, can I solve left and right? I don't know. I mean, it might be that it is greedy, to be honest. It's just that I'm just trying to think about it in the DP way. I'm not talking a lot, and I'm trying to not look at the comments for spoilers. But actually, I mean, well, let's start with 0, right? It always makes sense to pop the 0 first, right? Because you get no coin from it, but it prevents future. Maybe it is that. Like you. What would, yeah. Then you kind of figure out relaxing. It's like a weird, and when I say relax, I meant like graph theory relaxing, like in a, it's almost like a weird Dijkstra type problem, maybe where you have like, is it greedy? Well, because, well, you definitely want to get rid of all the zeros. So we could definitely filter out the zeros because obviously the coins are 0, but also so that like future, because you never like given 0 and an adjacent number, which is any number, you want to pop the 0 first so that when you pop the real number later, like, you get coins from it. So I think that's fair. This doesn't look like greedy though, because I feel like 15, oh wow, this is a big number though. It's 15, but this is 40, so that would be a weird choice if it's greedy. Hmm. I mean, I think there is like a weird, maybe n to the fourth dynamic or something like that, DP, but that's clearly too slow. So I don't. Oh, one thing I maybe missed is that, I mean, I looked at the 0 part, but this is 100. Does that mean anything? Well, it means it's hard. You can't go over float. I guess maybe that means one thing, but maybe there's also some kind of state that you can keep track of. Um, hmm. Oh, I think there's like a fun thing where maybe, I mean, maybe greedy is the right word, wrong word, sorry, but there's like a almost like a comparison. I mean, mm, like okay, bursting one, like there's a function that's like second order or something like that. Like the cost function of the greedy isn't necessarily just bursting it, but it's like the sum or like some weird function on bursting this before bursting the neighbor or something like that. And there's some function on that maybe. And then once you do that, you can do a sort of a greedy maybe. Um, what's bursting this means you get 15, but it also means you're 5. So your cost function, what does it mean to burst this, right? Bursting the 1 means you have in the future in somewhere 3 times 5 more. I do like this kind of. I'm not gonna lie. I like this problem per se, but not as an interview, probably not. But well, maybe when I see the solution. But so I would like to, no spoilers, please. But why would they not pop 5 instead? Well, but like in this case, why not pop the 3 then? Why or how do we choose the 5? Okay, let me try to work out this example just to kind of see if I could work on an intuition. Let's say like this. You pop the 3, you get 15, and also your answers, that's your sub problem. Or 3, 8, but then you have 3 times 5 is 15 times 8 is 120, and then you get, oh, I wrote that weird, but, or you can pop the 8. So you pop the 8, you get 40, and you get 3 and a 5 left. Why do we make that decision? What does it mean to pop a balloon? Because I think, well, you add some coin, but so if you pop 5, the cost function is, so then you bring the 3 and 8 together. We'll do 8 instead of, so it's similar to, so you pop the 5, 8, then it went from, so you have 8 times 5 minus 3, just pop that, and then you have what, 3 minus 5, plus 3 times 5 to 8, so 8 minus 5, what's that? This is negative 16 plus 9, so that's negative 7. So that, in theory, that cost function is 113, maybe? Is that good enough for me to do greedy? In this case, you pop the 3, so 5 goes from 3 to 1, plus, well, that's it. Because you get negative 10. This is just 10. Like it's like a weird sorting-ish problem-y thing, but thanks for staying up, Postal Rat. Hopefully I see y'all next week. Today I'm trying to do a mini marathon, so that's why it's been longer than usual. Usually, because it's already 1:20 here too, so a.m. So it's not like but yeah, nice seeing y'all. Thanks for the support. Okay, 8. So if I pop the 8, the 5 goes from 8 to 1. So that's equal to negative 35. So this is 5. Okay, I mean, I guess this kind of fits for this, but like that does not, it's not convincing enough for me. All right, 3, 1, 5, 8. Let's try just like more generic. Okay. I should write that in code so I don't have to do it manually. That's what I'm doing. Okay. Let's calculate the cost of popping this balloon and changing the delta. Yeah, okay. Yeah, maybe it's for testing, just for intuition, so okay. So, okay. So we pop this balloon, we get the okay, fine. Maybe I'll rewrite this a little cleaner. I don't know how long this farm might take because this is one of those farms, I guess. And then I figure out the delta of this, which is some like weird cost function. So your left, what I'm trying to do here, when I pop 5, is calculate, well, your left has a delta from your number to, okay. Which I could have left right, but your left times, maybe I even need to go too deep. Man, this is just confusing me. Is this smaller, right? Let's just look at the shape of this function. This is the before and after. Yeah. Wow, people overwhelmingly like this form, so maybe I'm missing something obvious. So in this case, popping to 1 gives us -7 in the thing. I don't think that convinces me of anything. Well, except this is the lowest, but in this case, this is the highest, so it doesn't make. This is like the Leetcode version of one more round, and then your last round, you always end up like when you play video game or something, you're like, one more turn, and then next thing you know, your last turn takes like 2 hours. This is what it feels like. How do I choose which balloon to pop? I wonder if there's like a heuristic to kind of do it, versus some sort of dynamic programming. Sorry, I'm not talking loud. I've been talking for many hours straight, I guess. Okay. I don't know if there's an easy way to dynamic programming, only because I don't know. Once you merge something, things overlap, and your problems or your sub problems, you need to know where it began. Or yeah, that way. I think there's a dynamic programming solution, but I don't think it's fast enough. Because it ends, maybe even end to the 5th or something. So all those are constants. Yeah, n was smaller maybe, but think I do have a cool dynamic program solution, but seems like maybe not. Maybe it's a greedy with a odd cost function. Hmm. There's no idea of left and right. When you pop a balloon, I'm still thinking about it in terms of subproblems. Maybe that's the wrong way to think about it. Maybe this is kind of a figure out the cost function, or like the true cost of popping a balloon, which is not just the number of coins, but it means other implications that I'm not doing a good job of thinking about. Which is what I was kind of trying to see about, this shape or these things. All right, let's go a little bit. Please case. Right. Okay, just one balloon you pop. Okay, that's a way. Yeah. There's two balloons. I guess this actually doesn't matter what order it is if there are two balloons. Like the answer is still going to be the same. No, wait, that's, yeah, no, that's not true. With two balloons, you pop the lower one first. Yeah, okay. Why do you do 5 here? I'm going to cheat a little bit. $52. It's like 120 plus 24 plus 8. So it's 152. So why not 3? What happens if we do 3 first? Maybe the greedy is popping the smallest balloon until you have 3 balloons. And then maybe after the 3 balloons you just brute force the ways. Because as long as you have 3 biggest number, maybe everything in between doesn't really or like when you choose the lowest, well, when you have 3 numbers, you pop the middle number. Some weird thing like that, maybe. Maybe it is just greedy, because the earliest you pop the smallest number, then your numbers get bigger together. I think I was just overgeneralizing the n equals 3 case and n over thingy case. Let me try that and then we'll see. Okay. And with that, you could actually do what you call it, a heap. But yeah, I'm not going to. I'm just going to do it greedy a little bit. I'm just going to do a for loop to calculate the min, just because I think it's slightly easier to code. And I think for now, I'm just in my testing my hypothesis mode. So yeah. So I think, I mean, yeah, I guess we'll see. Only edge case I think is around the edge, maybe. Do you pop a low one that's on the edge? Yeah, maybe you do. Yeah, maybe you do. I think you do. Also, if that's the case, I mean, I'll explain why if you're about this problem later if that's the case, but okay. Yeah. Maybe I could modularize the third function, but now what am I doing? Okay, maybe write this. Sorry, it's a little late, but maybe my thinking is a little off. Actually, I had most of this code earlier. Well, but I erased it. Well. Hey, we don't even need to. Oh, I need this to. Yeah, I need this for calculating the coins, but I don't actually need this now. So I messed up a little bit. I don't know what I'm thinking. It's just late in the day. Maybe this is my last problem then. Okay. So what we said was we would take the smallest number. Right? Because I started implementing stuff that is what now I was saying, so that's not great. These are less than 100. So okay, the smallest number. Let's just say. So there should always be something. Okay, and then now we merge that number. Cos. Oh, I guess this is if it's greater than 3, per what we said earlier. So now we get let's do that. No. I guess this is coins, not cost anymore. Okay. now that we got it down to 3, we get them, well, actually we want to get rid of the, we still want to get, we still want to get rid of all the zeros even before 3, okay. Oh, and I also don't erase it. Was it plus index, something like that? What's a clean way to filter? I don't even know. Okay, so now we should get numbers down to 3. Let me just compile the code, see if it compiles. Okay, it compiles. Wish it did something though. I knew that wasn't going to do anything. Because, let me just at least do this so I can see one iteration of the loop. Also maybe add a bunch more answers. Okay, 3 is where it gets interesting, maybe. Well, we already erased all the zeros, so this wouldn't happen if, okay, so there should be no zeros in the remaining answers. Then, okay, so we just maybe do a case if, so you want the middle and then the smallest number, and then the biggest number, so okay. For 3. I don't know if this is too greedy. Maybe I'm wrong in some places. So 1 times. Unless one of the numbers is 0. No, we already removed all the zeros, so there shouldn't be zeros. Plus, do the smaller number first. Okay, fine. Well, you need to, both the numbers will give you the same sum, or same whatever, and then add the smaller of the 2 numbers. No, the bigger of the 2 numbers. That's the point of popping the smaller one. But there are other cases because of removing 0. So if you have 2 numbers, well, it's similar to here, which is yeah, okay. So if you have 2 numbers, then you pop the smaller one. That means you add this bigger number twice. Yep. And this 1, then just pop it. To be honest, not convinced at all about the solution. Is very hackney, but yeah, I mean, I think, well, I guess it has to be less than 100, but also if it's not the right answer, I don't know what I'm going to do. I'm just going to do a bunch of stuff. Oh man, so greedy is, doesn't seem like it's right then. Oh well. Why is that? You pop all the ones. Alright, so this is kind of what we're talking about with the, we have a bad idea, then what do I do? Well, I'm going to break it down to easier components to understand and then see where it goes wrong. Okay. Seems reasonable. So do you pop the 2? Let me put it in a text pad somewhere so I can keep track. Okay. So in here, my strategy is to pop the 2. But maybe that's not right. No, that's not right. Well, I actually don't know. But, well, let's even make it, we'll keep going. Yeah. And then you pop the 15 in, so is this right at least? Okay, so the 3 case maybe is right. But okay, let's just add one more numbers back in. So the answer here is not to pop the, well, 113 shouldn't be an input. I messed that up actually, but it shouldn't matter. So what, maybe I think I have a similar other strategy, which is to take the biggest number. I mean, I think what I'm thinking of is take the biggest number, or maybe you want brute force. Because I think what I noticed here is that you kind of actually want the biggest number in the middle, right? Maybe, at least as best as you can. And then, I don't know, what is 500 cube again? 500 cube is huge. And then all the other numbers are just in between and kind of, are those your subproblems? Okay, given 2 numbers, how do I merge all the intermediate stuff with that as the border? Maybe that is the dynamic programming. Does greedy work? Right. So I say I wrote a lot of code, but I do think I am getting a little bit of insight of maybe the right version of greedy, maybe not. Maybe making some progress anyway. We definitely need this to get rid of the zeros. I think it does nothing for us except for give us negative score. Well, not negative, but effectively negative. I think this part is what we have to do. I think this part is also should be mostly right because there are only a number of cases. But we maybe smarter about this greedy per se, which is that we want to get maybe not even the biggest number, but like what is the biggest middle number? Well, the biggest middle number, or the best number for the middle. Can we do it that way? Well, is it path dependent? I guess not, because you always pop stuff around it. But is there a case where you want to pop like a couple of 99s in the middle? No, because that would be one of your outer conditions, and then you have to figure out how to adjust it. Man. Thanks for the tip. Let me think about it. I was thinking about this a lot already. Oh yeah, I mean Yeah, I think I was like, yeah, getting to thinking about it along those lines. Thanks again for the tips, M score blacks. I mean, that's why I was kind of thinking about like, what does it mean for you 100? And I'm like, well, like you were saying, what if that's already if that's the last bubble? Like I said, it's never greedy, but that's the last bubble. What does that mean? Well, how do I restructure the problem to like what are all the intermediate paths in between, like the left and the right? Okay, I think I see what you mean actually, and I think that's how you structure the dynamic programming. And it but still n cubed though maybe. Uh, yeah, okay. I'm gonna copy and paste this code just in case, just for reference. But yeah, I think yeah, I'm gonna blame it on the sleep. um, yeah, because yeah, I think the key insight, and I was kind of like I don't know, you might have missed the point where I didn't want to hit, but and not trying to flog it, but because I was trying to figure out how to man, I should have gone this faster then. But I was trying to how to kind of separate the subproblems, and but I was thinking too much about solving the problem first, or like first to pop. But if you're popping the balloon last, then it's a clear separation because by definition, if you're popping that balloon last, then all your left will have to, you know, yeah, okay, yeah, that's n cubed. I mean, I'm hand waving a little bit, but I think I have the idea in my head, so maybe I'll explain it after if I get it right. But now that is a little sad then, because I should have gone that faster if that's the case. But what's the max 500? Okay. Uh, let's just use -1 as a placeholder for now. Uh, that's why I need more practice. Never had no practice. Okay, from 0 to n-1. Mm, mm, No, we have the proper balloon, so it's an okay default thing. Set a no value if you want to go there. Well, am I doing this right? I mean, this is the right structure, or if that was the right thing, but okay. So let's say you picked I balloon to pop, and now you have left and right. How did you get the number for the cost? Is it? Okay. So you have something like calculate left I-1 times, but that's the main cost, not the value, right? Oh, mm, I guess I could just store another thing. I just didn't store another thing. Yeah, okay. Maybe that was the missing key that I was. Is that what you wanted? Because the best optimal things might not be. So if we take this as your last number, last balloon to pop, so you mean you pop all your left balloon except for one balloon. What does that mean? Or at least I'm trying to figure out what does that mean for. Maybe left right is not the right formulation. I was stuck on this a little bit earlier, but because the best here, the cost is you go to, this is the best number of coins you can get is the left, the right, plus what you get for getting this one, which how do you get the but this you maybe need to take a loop, right? Depending on your second, or like your best on the left and your best on the right. And get an NQ thing in here, that would take way too long. So you could reduce it to 100. Maybe I could abuse the fact that it's less than 100. Yeah. Even then, it's like 10,000 times 50, 100 times 500, or 500 times 500, which is 25,000 times 10,000. That's way too much. Man, today is not my day. That's what I get for bragging about the other problem as well. Maybe this is one of those cases where I actually learned something. I mean, I know a formulation that goes with this, but then it requires you to add a dimension, which I don't think we could afford. And also, there's a dimension here, but which also we can't afford. And it's 2 a.m. I think that's why I was kind of thinking about it toward greedy, but okay, I feel like I'm close. Oh, well, if DP is the DP is the reason, then that's how I would think about it. But well, it is memorization. Maybe there's a clearer thing about it. I feel like this is also standard, but yeah, I'm just trying to figure out how to calculate the score, right? I mean, I think I have essentially this is the left subproblem, this is the right subproblem, and then I'm just trying to figure out the cost of or the score, if you will, of this one. How do you get the left and the right? Like how do you choose the ith, like the smallest index to get the score? Am I doing this weird? Oh man, I guess it's time for me to do some learning. But yeah, or maybe I guess we have to burst the left one eventually. So that means, oh, so that means, I guess left is implicitly the last one you're bursting. So I guess the score is, I think I formulate this a little wrong. Just want to formulate everything in between, and then you do the thing last on the border. Such weird. I have to maybe read about this a little bit. Let me play around with this and then kind of figure it out. Which is I something like that maybe. Yeah. If that works. I don't know what. I might have to explain some things now. Maybe I formatted my DP a little weird. Well, this. Well, yeah, I have to do bounds. I understand. It's fine. But thanks for the help, though. Yeah. Okay, fine. Well, no, it's too late in the day. I'm just gonna hard code it for now. So this left part is 1. Well, think my intuition was a little bit off on this one, but well, I just yeah, I don't know. That was very close, but maybe not. I think this function was kind of the one that I had trouble with. I think I probably don't have the correct base. Well, I have no base case, so of course it's not right. But yeah. Is that enough? Still no. Why was it recursing? Oh, I see. I think it's this part. Or well, I guess I know this part. No, there's only one number. Oh, it's n. What am I doing? Sorry, friends. It's just later in the night. There we go. I think my thing is just weird altogether. Thanks for the destroyer. Oh, also dinosaur crowd made a comment. Okay, cool. Okay, well, is that right? Good. It is something. I need also one more case, maybe. Sorry, I'm a little slow. That's all. It's I'm on my 7th hour of Leetcoding on Twitch, so that's my excuse for being a little slow and tired. But which is the longest I've done. But you know, on an interview, you need to do stuff for like 5 straight hours, so 5-6 straight hours. So I don't think that's a reasonable excuse. Well, hopefully, maybe they're slightly easier. But okay, what am I doing? Okay, let's start with some base case. I probably have an off by one somewhere. I just don't feel like this is roughly right, maybe. I mean, except for maybe one of the cases as well. Okay. Wow, that took way too long to run, but okay. Yeah, they feed you and stuff too. Yeah. Thanks for the support for the destroy. Why is it so slow though? What am I testing though? What is this one? What am I doing? I mean, that number is just outrageously wrong too, not just a little wrong. Have one numbers to pop. Okay. Maybe I double counted this actually because I just already factored that in. So maybe this is just 0. Oops. Maybe no. Is that true? Mm-hmm. No, this is for when there's 2 numbers. So I don't know. Okay, this number is just still wrong. So maybe this is fine. I must have double counted something. Yeah. I think I've inverted this. Oh wait, no. On the I side, the left side is 1 because that's just a war. right? Then you just take the right and then get the thing that's in between. Okay. Left, and then you get the thing that's in between. Yeah, I agree. That's what I've been trying to do a lot of them. But yeah, today it's just been exhausting, maybe. Now we're into this one. Let me just see, make sure I at least get some of these right. I guess I don't even need. Well, I get that one, so at least that's good. It means that I don't know, somebody just really well. It's off by 9,000. I think my two number ones are right. Why is my three numbers wrong? Check that assumption. Okay. Oh, I get the middle one. Oh man. Oh man, I forgot that I changed. Sorry, it's very late. I forgot that I changed. That's what happens when you. Yeah. When you're hacking things late at night and you just change one price and you know that you have to change another prices. Okay, it's still wrong, but at least it's more right, which is good enough for me. Well, not good enough for me yet, but good enough for now. Yeah, I mean, what you don't know is I'm just actually delirious. Also, I had too much caffeine, so I've been eating to use the restroom all the time. But this is on the right, and yeah, because this is other times one, so you have all these other things. How does this get wrong? There's only like 6 possibilities. Do I just have a typo or something? Probably here. Because these two works, maybe not. Also, I don't know why I want the stuff this way, but now that I don't know, I think I try to rush it, and that left me to do things in a way that I'm not usually do DP this way, which kind of I don't know, silly mistakes. Let me at least clean up this code a little bit. Now I know. I think it should still be the same thing, but at least it's easier to read. Oh, well. Is that true? I guess it's true. I mean, for 2 things, it's been right. Maybe. Man, I am struggling with this problem right now. Is this right? Maybe my base case is wrong. what does it mean when left is equal to right? That means you have one number. Is this going to crash me? Yep. I think that maybe I have to do, maybe I don't pop the last balloon well. No, let me. Well, I guess we tried to do it to 0 and then change the answer, so. Is that true? No, it did change. No, it didn't. So I mean, I don't know if this is right, but it did not change the answer. What am I doing here? Okay. So we can actually manually calculate this and figure out what, but we pop this one. So well, now what does that mean to pop your left? Yeah, you times this and the thing. No, this. I'm kind of think that's right. Oh my god. But that means you pop this, you recurse on 52 to 73. And then man. I also have to like take care of zeros at some point. I think I mentioned that earlier, and I think it's still useful, but maybe I'm off by 1. Yeah, maybe this should be something like that. Except for we have to handle the edge cases again. Yeah, okay. Let me do something funky. No, let's get rid of all the zeros first. And then maybe we well, let's just create the boundaries. I think that's I don't know why I didn't do this earlier. Divorce, if you will. And then now we could do, and then just maybe that. Maybe that simplifies in some edge cases. Well, it did something. Oh, I think I didn't do this one. No. So if there's 1, then you. Okay. We're on the right track again, maybe. Maybe not. We're a little off. So not quite. No, I think this one has to be a little bit more. So you pop this, you get left -1 and then +1. I call it cost just because I'm used to optimization, but this is actually just coins or something. I don't know, like the sub problems. Okay, well, maybe I don't need. Do I still need these now that I have? Now that I put in the ones, maybe not. Yeah. Let me simplify the problem a little bit more. There's two points where I can debug. I don't know. Oh, Jesus. How does that even? I don't know what. I mean, it works, but if you ask me if I believe in it, I don't think I do. What's my list of answers or questions or not or whatever from before? Okay. Okay. Well, if I don't terminate early or there's like a. Oh yeah. Well. Yeah, I still have an off by one somewhere. That's fine. Oh, no. I'm definitely doing something funky because I can definitely be less than left. Just look at my code. What am I accessing? That's not right. To the right. Well, this is just wrong. That's why. But now you want that, so maybe it was right. But do I use n anyway? Not really. Oh man. I was hoping. I mean, I got one little closer, but also maybe a little closer to death. What is this negative thing? I mean, definitely, I shouldn't have any negatives. I mean, this is a. How do I even get negatives in here? Well, I mean, is it accessing random memory? I mean, it's probably just that. That is accessing random memories. So like there's an out of bounds I didn't get checked somewhere, but that sounds more likely. Okay, this actually seems more likely, but at least that's more likely than an overflow because all these should be integers, or like integers less than 100 even, unless I did something wrong. Man, definitely need to use the restroom again soon. But I don't get it. Because this should be at most 1, or at least 1, and at most n minus 1, and a new n. So plus, oh wait, maybe this is -2. Maybe I messed up. Okay, let's try that. Yeah, because n minus 1 is the last bound. So n minus 2 is the one with the 1 at the border. Okay. Okay, at least I fixed something. Still wrong though. Uh, and that's why I need practice with dynamic programming problems. I definitely need this because I forgot I wrote out the zero, so you can't just take nums. But right. I think I have enough to look at the subproblems at least. I was so close, I felt like I got that one other answer right. Okay. Zeros definitely should not be a thing, so let's see why that is the case. We have two numbers left. You have 1 and 2. What do I do in that case? Oh, because of this never. Oh man, so all the things I did to. Okay. I guess all the stuff I did to. I don't know why I did. Okay, let's just keep it clean. If I stop that. Should have done that a long time ago, but have been struggling with it off by once. Maybe dynamic program problem is not the way to cap off a 7.5 hour stream. Okay, so I mean, okay. Once again, thanks for the hint. M_Brax. I mean, I don't know. I want to say I would have gotten there eventually, but knowing today, maybe that's not true. I've been able to know. Okay. Just YOLO. I'm a little too tired to put in even more test cases. Okay, cool. Wow, I'm really slow too. But even n cubed takes only 68 milliseconds, which is actually surprising maybe. I don't know why. Maybe the test cases are a little lax. How do I feel about this? I think, yeah, first of all, yeah, I mean, postmortem or a retro on how I solved the problem. I definitely did try to, I think in general, I mean, I could have obviously skipped the greedy, but I couldn't come up with a really quick edge case for greedy. So I was trying to at least implement it to kind of get intuition about it. I think for whatever reason, I just didn't visualize the dynamic program fast enough. I also, I don't know. I think I struggle a little bit with. I thought n cube would be a little too slow for n is equal to 500. Maybe I gotta do my math a little better. Because 500 to cube is 125 million. Maybe that's fast enough. Yeah, maybe my internal clock has to be a little tuned for it. Yeah, exactly. And I was doing it forward. I think at some point I did after I did the greedy thing. I'm like, wait, maybe the greedy thing prompted me to look up things to think about it in terms of what happens if I kept this balloon until the last balloon, and that kept me, and then that in a weird, maybe unnecessary but a long roundabout way allowed me to kind of think about dynamic programming again, where that was the last balloon to pop, and that helped me have a separation about left and right. But I think so. One thing that I did want to point out a little bit is, and my obviously I also had help from M_Brax, for which I'm thankful. Which unfortunately, uh, you know, M_Brax is not going to be at my interview, so I definitely needed to be able to do this by myself. Like little maybe what's it called, AirPod cheating advice or something. No, but um, so I think I didn't formulate. I mean, I think something that I definitely did a little bit bad on is well, one is I didn't filter out the things and reset up the problems a little bit. I should have created these walls a little bit earlier, just to kind of so that I have fewer edge cases, because I was doing weird things as a result. But also, yeah, I mean, I think I have to get a better sense of. I mean, and if you watch me, I don't know how carefully because I kind of did this for a bit. But if you catch me on the stream, I set up most of this immediately, and some of that's by just from experience. But that also kind of worked against me a little bit on this problem because I thought I was very close to the end when I didn't have a clear formulation in my head, which led to me having weird, like a weird-ish off by ones on the sub problems, and also the cost because I was using left and right because I was just like in my head I was like fudging. I was like, maybe I'll get it if I just kind of get it. And sometimes it works, but in this case I kind of paid the price for it. Um, but if I had kind of really stepped back and really formulate what this function means, what does it mean to calculate left and right, and excuse me. And I think once I kind of did that, which was the which is the best cost that you can, uh, given that you populate one of the or you popped one of the balloons between left and right. That's the man. Even now, I'm struggling a little bit, to be frank. Uh, but that's just the best, the maximum number of coins that you can collect, popping left and right last. Uh, yeah, uh, yeah, and I think I struggle a little bit with kind of, and I guess to that point, and I kind of played around it with a little bit. Uh, Wait, is that true? What am I saying? I'm saying it a little weird still. Um, so I think, sorry, let me get it together in my head so I could kind of formulate this subproblem a little better. I think the subproblem, or which is the part of this recursion, is the max score or the max number of coins between the max scores that from within that range, where where the max score is popping a balloon, in that range, last. To be honest, I'm not convincing myself either a little bit. Maybe I have to think about it. But like if you pop a balloon on and in this case, if we pop the leftmost balloon first, then you pop that. Oh, sorry, you last. So if you pop the leftmost balloon last, then that means that everything from yeah, I'm saying it really wrong. But for example, if I is equal to left, meaning you pop the leftmost balloon last, it means that you can only have the borders, which is right plus one and left plus one, which in a really default case is just edges. And the same in the right. Um, and in the middle of any of those balloons last, that means, yeah, I'm struggling a little bit. Yeah, I think the struggle for me, like, and this is like the setup of this problem, and there are not many different types of setups for dynamic programming. So like I have all the setup correctly. I think it's just that the formulation, which determines the cost function, changed a little bit. You saw me struggling a little bit on thinking that from left to right, there's you also need to know the maximum balloon that's within that range, but that's not true. Uh, because all the balloons are already popped. So you're assuming that the last balloon that's popped over there, you don't need to return the balloon that was last popped because you already popped for the cost function, which is here, because everything in between is already popped. And that was the part that I was struggling with a little bit. But I think as a result, I think one thing that I am trying to figure out how to do better about is, yeah, I mean, I guess I solved this problem a little bit, and I guess I know how to solve this particular problem if I see it again. But what I need to do better is figure out, well, what am I or how am I learning from this, and formulate this problem in a way that if I see not a similar problem, I could solve it way much better. Um, eh, Maybe I chalk it up to a bad night, late night, but still, I wish I could figure this out a little bit better. Because you already popped all the balloons from left to right, and all you left, and that's why this one doesn't have any, cost or whatever. The kicker is because you already popped all the balloons inside. Um, you're left with left of that range, and the right of whatever that range is, and that's what this thing is. And we have one balloon left, or if your range is one, then you just pop that and you get the immediate borders. I think I kind of I mean, I understand this problem, but I think one thing I'm also just trying to figure out in terms of learning is, yeah, how to kind of clearly formulate this. And I think thinking back, I kind of was one step away from thinking it correctly initially, where I was like, okay, because I think what I was thinking about is also like iterating the pivots or the sub pivots on the left and on the right, but I wasn't thinking well enough on the and which is why I talked about like the cost being not enough, but I think my sub problems were a little off in that I still worried about um, the numbers to pop, but in that case, or the last balloon to pop, in that case, my sub problems were wrong anyway. But I was just kind of doing it out of habit. I mean, I think that's what I would say that's what the pattern matching buys you is that, or like from being familiar with these DP problems, is that you get so good at kind of writing these templates, but you still have to understand the problem to really solve it. And of course, again, thanks Ambrax on walking me through it a little bit.